Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine the slope between 2 points. Now, basically, when determining the point between two slopes, determining the slope between 2 points, basically what we're doing is we're looking for the rate of change between the x-coordinates and the y-coordinates. So to understand that, we got to identify, well, what are the x-coordinates, what are the y-coordinates? So remember, when you have a coordinate point, you have an x and a y-coordinate. But when we have 2 points, you have 2 x's and 2 y's. Now, it would be nice if we could always differentiate our x's with colors, right? Red and green. It'd be easy. Because if I say, what's the red x, or what's the red x coordinate, you say 8. If I said, what's the green x coordinate, you'd say -4. But if I just say, what's the x coordinate, you have 2 options there, 8 and -4. So on your text, on your textbook text, on your homework and your notes and so forth, we don't use colors. But what we do is we just distinguish our coordinates by using subscripts. So I'll say x1, x2, y2, y2, x2, x1, y2, y1. And that just tells us, so now I don't have really an x. I have an x1 and I have an x2. But they still represent the x coordinate. So when using the slope-intercept, basically we're looking for the rate of change. How are things changing? And remember, when you look at something, the change of something, you're looking at the difference, right? If I say I'm 35 years old and you're 15 years old, what is the change in our age? Well, basically, that's the difference. You're taking 35 minus 15, which would be 20. I'm not 35, and I have no idea how old you are. So when we look at this, so to find the change, we're finding the difference. Basically, we need to subtract. So we can go through our using actually the slope formula. And the slope formula, where m represents slope, is the change in the y-coordinates over the change in the x-coordinates. Now, you don't have to do y2 minus y1, x2 minus x1. You could do y1 minus y2 and x1 minus x2, as long as you are consistent. And the other thing that comes up, you don't have to label the first one as 1s and the first ones as 2s. You can switch that as well. It doesn't matter which one's which, as long as you are consistent, as long as x1 goes with y1. All right, so basically, remember, slope is always the change in y over the change in x, or rise over run, right? So the change is going to be the difference subtracting our y-coordinates over subtracting our x-coordinates. So I'm basically going to use that formula here. So m equals y2, which is 3, minus y1, which is 9, over x2, which is -4, over x1, minus 8. So now I simply just subtract across. So 3 minus 9 is going to be -6. -4 minus 8. Remember, subtracting, if you owe me $4 and you subtract, if you borrow $8 more, you now owe me $12. So 12. -1 divided by negative divided by negative is a positive. 6 divided by 12 can be reduced to a positive 1/2. So m equals 1/2. OK. In the next example here, again, we're going to be doing the exact same thing. So we just go through our, I always like to label them first before I get into doing the formula. OK? So now, again, just follow my formula, y2 minus y1. y2 is -4 minus y1, which is 4, over x2. x2, which is 1, minus a -1. So we have -4 minus 4. If you owe me $4, you borrow $4 more, you have a -8. Divided by 1 minus a negative. Remember, a double negative, 1 minus -1, is basically going to be a double negative. So we're going to add them, which is equal to 2. -4 divided by 2, or -8 divided by 2 is -4. So we could say m equals -4. Or if you need to use that in a fraction way, like if we're graphing it, you would just write it as -4 over 1. OK? But -4 and -4 over 1, same thing. OK. So now, again, we go to another set of points. We have 0, -3, and 3, -3. So I go ahead and label them x1, x2, x1, x2. And then I just go ahead and determine, plug them into the slope formula. So I have an m with 3 hoops, which goes -3. Oops, what am I doing? See, I'm getting lazy, and I'm like talking and not paying attention. x1, y1, x2, y2. OK. So I have y2, which is -3, minus a negative -1. And I should have done that over here. When you're entering these in here, especially when you're entering in a negative, make sure you use your parentheses, because this is one of the common mistakes. Students will see -3 minus -3, and they'll only use one subtraction. Well, it's -3, it's y2 minus y1. y2 is -3, y1 is -3. So a lot of times when you're entering in there, when you're subtracting the negative, put it in parentheses so you remind yourself that it's a double negative. Over x2 minus 0. OK. Well, -3 minus a -3, again, that's a double negative. So I have -3 plus 3, which ends up giving us 0. 3 minus 0 is going to be 3. But 0 divided by any number is 0. So m equals 0, which it's important to note that when the slope is 0, we have a vertical line. So it's still going to be 2 points that are still going to have a slope of 0, but it's going to be a vertical line. And then over here, again, we'll just do the last one. So x1, y1, x2, y2. So m equals y2 minus y1 over x2 minus x1. Well, 2 minus 5 is -3 over 6 minus 6 is 0. Remember, you cannot divide by 0. Or when you divide by 0, you have a value that is undefined. What am I doing? That is not vertical. That's a horizontal line. Sorry about that. Don't mean to confuse you. So m is equal to undefined. When you have an undefined slope, that creates a vertical line. If the 2 points lied on the line, it'd be a vertical line. But I just thought it'd be important to kind of note that, because here you have a positive slope. Here you have a negative slope. Here is a horizontal line. And here would be a vertical line if you were to connect the 2 points and make a line. So I just want to make sure you're aware of that. So there you go, ladies and gentlemen. That is how you identify the slope between 2 points. Thanks.